Welcome to Lesson 4 and 5 of Module 3, where we will begin using our place value knowledge from Module 1 to help us with our understanding of multiplication and division in Module 3. Now, our first couple lessons here with Module 3 are going to deal with, again, our place value chart and place value disk so that we can start building on some very basic multiplication here. So if we look here at this first problem, we are going to be drawing place value disks and arrows to represent the following expressions or equations. Now these should look pretty familiar to you because we have seen equations like this before, only with addition and subtraction. But let's look here at this first one. We have 3 ones times 10 is going to equal how many tens? This is a question mark for us right now. How many tens will that end up being? So just like before, I want to start with what I know. I know that I'm starting with 3 in the ones. Now, when I multiply by 10, I know that I'm going to end up having bundles because there are 10 in a bundle that we have to send over. But as we gather towards the end of Module 1 last time, I also know that when I multiply by 10, what that means is that I end up taking whatever it was that I multiplied by 10 and shifting it over to the column to my left. When I multiply by 10, I send it over to the column on my left, which means that this would happen to end up in the tens place. Now, if I think about, well, my question mark, how many tens does that equal when I multiply 3 ones by 10? My answer should be 3 tenths. Okay, let's build on that now and let's look at the second problem. We now have 3 ones times 10 times 10 equals 3 what? Alright, well, I know that 3 ones times 10 is 3 tenths, or 30. But if I multiply that again by 10, well, we just talked about this. If I multiply by 10, I'm sending it over to the column on my left. Exactly what I had there in the tens place, I'm sending now over to the hundreds place. So I now have 3 hundredths. Okay. Well, let's look down here at this bottom one. We're going to build again on the 2 problems that we've just done. We now have 3 ones times 10 times 10 times 10. Okay, well, let's use what we've already done here. We have 3 times 10, we said was 3 tenths. Then when we multiply that by 10 again, we got 3 hundredths. I'm hoping you're jumping ahead here. You're thinking ahead, and you're thinking that when I multiply by 10 once again, that I'm going to move over to the place value on my left, which will end up with 3 in the thousands place, giving me thousands down here on my blank. Now, if you look back, this should make sense here because as I'm looking at times 10, times 10 times 10, and times 10 times 10 times 10, well, my numbers here, my 10 would stay the same, but if I multiply 10 times 10, that's a math fact for me. I should be thinking, well, that equals times 100. And I'm sure that if I asked you what 3 times 100 was, you could probably tell me that it is 300. Now, if we look down at this third problem, 10 times 10 is 100. Times another 10, well, if I move 100 and I multiply it by 10 and I send it over, I'm going to end up with 1,000. So it would be like saying 3 times 1,000, which I know would be 3 thousandths. Let's apply the same logic to a new problem. So now we've got the same directions, draw place value disks and arrows to represent the value of the following expression, 22 times 100. Well, we just talked about this 100 is like saying times 10 times 10, because 10 times 10 is 100. So I want to take 22 times 10 times 10. Now, if I want to represent 22 in my place value chart, I've got a 2 in the ones place, so I need 2 place value discs in the ones place, and I should have 2 place value discs in the tens place. Alright, if I multiply by 10, that means I'm going to bundle and send over times 10, bundle, send over times 10. So now I've got 2 in the tens place, 2 in the hundreds place, but I'm not done because it wasn't just 22 times 10, it was 22 times 10 times 10. So I've got to do this now again. So now I'm going to bundle once more, times 10, times 10, and I should end up with 2 in the thousands place and 2 in the hundreds place. Now, if we look at my times 10 times 10, I've now moved twice in each place value. So I moved my 2 in the tens, 2 place values, and I've moved my 2 in the ones, 2 place values. So my final answer should be, I now have 2 in the thousands, I have 2 in the hundreds, I have nothing in the tens, and nothing in the ones. If I'm looking about where I should put my comma, I go 1, 2, 3, comma, and my final answer for 22 times 100 is 2,200. Alright, now I want you to practice this problem on your own. So, again, we're going to draw the place value discs representing the following expression. I want you to pause now, go ahead and practice this on your whiteboard or notebook paper, and then go ahead and play once you finish and see if what I have matches what you have. And if not, where is the mistake? So I'm going to first demonstrate my 15 in place value discs. I have a 5 in the ones place, so I'm going to have 5 in the ones. I've got a 1 in the tens place. And I'm now looking that I have multiplied by 1,000, which means I'm going to take times 10, times 10, times 10. Or I'm going to end up moving 1, 2, 3 times. So I can do this individually 1 times 10 at a time, or I can do it all at once. If that you feel like is going to confuse you, then move it times 10. Regroup times 10. Regroup times 10. You don't have to move it all at once unless you feel comfortable with doing that. I'm going to go ahead and show you what that would look like if I know that I'm going to be moving it 3 times. So I need to move this over 1, 2, 3 place values times 1,000. Put my comma in there. I'm going to add a 1. And if I bundle and move this over 1, 2, 3 place values times 1,000, I should have, oh, I missed a dot in there. There we go. I should have 1, 2, 3, 4, 5 in the thousands place now. So there's my final bundles. I've got 1 in the 10,000s, 5 in the thousands, nothing in the hundreds, nothing in the tens, nothing in the ones. So my final answer for 15 times 1,000 times 1,000 equals 15,000. Just like we know that 3 times 100 is the same thing as 3 times 10 times 10, I can use that same logic to solve a problem like you see over here on the right, that 4 times 20. Now let's think about how you could represent 4 times 20 in a different way. So some ways you might be thinking are 4 times 2 tens with your unit form. You might think about 4 times, and if I break that 20 up, I know that 2 times 10 is 20. Or you could even be thinking ahead and thinking, well, 4 times 2 is 8 times 10 gives me 80. But how would that look in the place value chart? We've done the math, the arithmetic, but how would that look in the place value chart? So what I want us to do is focus here on this one right here. We're going to look at this, 4 times 2 times 10. Well, if I have 4, I start with my 4 in the ones place, because that's what my original problem had, and I multiply that by 2. Well, we already said that 4 times 2 equals 8, so I'm going to make, I've now got 2 rows, 2 rows of 4, and that ends up giving me 8. Well, now when I think about how does this look like when I multiply by 10, I bundle. I know I'd end up with 80 if I drew out all my place value discs, but I also know that I can just send them over to the next place value. But when I send them over to the next place value, when I times by 10, I end up with the same amount of place value discs in the tens place, which is 8 in the tens, and I now have 0 in the ones. This matches exactly what we had before. 8 times 10, math fact for you, 8 times 10 is 80, and I've now represented it in the place value chart as well. That when I multiply 4 times 2, and I move it over, because I multiply by 10, I get 8, or 80. Same thing as 4 times 20. If I were to show 20 4 times, if I were to draw that out, I would in fact get 80.